Good morning, very good afternoon, everyone. I want to thank you, all the attendees, on behalf of BC Care Providers Association for joining this webinar. My name is Abhijeet Singh. I'm an Energy Specialist at BC Care Providers Association. We run Energy Savings Program in partnership with Fortis BC. We wanted to acknowledge that this webinar is delivered from various offices located on the traditional unceded territories of Musqueam, Squamish, Tsleil-Waututh nations. We are grateful to live, learn, work on these shared lands. This webinar will be of 1 hour duration and will be recorded. I would request you to please keep your mics muted during the presentation, and if you have any question, please put them on the chat. We will have 15 minutes question and answer session in the end. Next, please. For this webinar, we have Impact Engineering as our educational partner. Kenneth McNamee is a principal at Impact Engineering, and he will be presenting today. Next, please. So today's agenda, what we have with us here is brief about CleanBC Roadmap 2030, impact of CleanBC Roadmap on building infrastructure, new building construction design, ways to improve building efficiency, gas and electric, success stories, case study from 2021. Next, please. So CleanBC was launched in 2018. After its launch, it was evident that the modeling left the plan with an emission gaps. After understanding the gaps, the roadmap to 2030 was created to take the lead from CleanBC and even further. The CleanBC roadmap to 2030 is planned to achieve 100% emission target while developing a cleaner economy. It includes a range of accelerated and expanded actions across 8 pathways: low carbon energy, transportation, building, communities, industry including oil and gas, forest bioeconomy, agriculture, aquaculture and fisheries, and negative emissions technologies. For this webinar, we will be focusing on buildings. Next, please. In the CleanBC roadmap, building section talks about the increasing adoption of energy step codes, which set building energy efficiency standards, then the base BC building code for new constructions and retrofits. However, we still rely on fossil fuels to meet more than half of our energy needs in buildings. Presently, requirements for new construction focuses on energy efficiency, but do not address the issue of GHG emissions, carbon emissions. 2030 roadmap not only consider higher energy efficiency, but also accounts GHG emissions / carbon emissions. That's why a new carbon pollution standard will be added to the BC building code, supporting a transition to zero carbon new buildings by 2030. It is mentioned that after 2030, all new space and water heating equipment sold and installed in British Columbia will be at least 100% efficient. Electric resistant technologies like baseboard and electric water heaters are 100% efficient. They convert all energy into heat, but heat pump exceeds 100% efficiency by catching and capturing moving ambient heat without producing it. The new requirements will encourage people to install electric heat pumps while continuing to allow the use of electric resistance technologies. They will also enable hybrid electric heat pump gas systems and high efficiency gas heat pumps. So on the right-hand side, you can see all these 5 measures would be introduced in the BC Step Code 2030 plan, which will allow to reduce GHG emissions and as well as include energy efficiency to the building. Next slide, please. So now we see that how the CleanBC roadmap tells us to move towards electrification as well as support in reducing GHG emissions. But here are the barriers and options. So now, as you are aware about CleanBC 2030 roadmap, you might be thinking of what to do next. So that we need to figure out together. We don't have a clear straight line drawing which says what to do, but depending on your existing infrastructure, you have some measures and options to work on. Moving towards electrification for retrofitting or new construction is not easy, as it comes with a high capital cost. Depending on the equipment, the running cost of an electric equipment can be higher, but has a lower carbon footprint. On the other hand, sticking to conventional natural gas system, which are cost effective, but have a higher carbon footprint. So the electrification helps us to have a lower carbon footprint, but more capital cost. And on the other hand, it is like cost effective, but higher carbon footprint. Regarding the energy efficiency measures, Kenneth will educate us moving forward what I wanted to, what these measures will be to work on higher energy efficiency measures. But I would like to draw your attention towards renewable natural gas, which is called RNG. So what is RNG? When organic waste like rotting food or cow manure decomposes, it releases carbon dioxide, CO2, and methane into the atmosphere, and also known as biogas. The raw biogas can be captured and purified to create RNG, which can be used the same way as conventional natural gas. It can be delivered through the natural gas system, and customers can use it in their standard natural gas applications. No special equipment or infrastructure is needed for buildings or customers. Using current natural gas system as a delivery infrastructure, Fortis BC can provide carbon neutral RNG, reducing the amount of conventional natural gas needed. RNG is considered carbon neutral as its emissions are way lower than the existing electricity. This means buildings can meet emission guidelines without the house owner or building owners incurring the expense of going fully electric. You may contact your Fortis BC account manager for more information about the Fortis BC RNG program. To better equip yourself or adhering the CleanBC 2030 roadmap, we would be creating working groups. I will be emailing you next month about what we'll be planning on making these working groups, and together working, finding solutions for your buildings, how you can adhere the CleanBC roadmap as well as reduce emissions. From here, I'll be handing over to Kenneth, and he'll be educating us about the energy efficiency measures and case study.
Perfect. Thank you, Abhijeet. Can you hear me okay? Perfect. Yeah, good afternoon, everybody, and thank you for the opportunity to speak to you guys today on some energy efficiency, low carbon opportunities that we've been working on here at Impact Engineering. So my name is Kenny. I'm a principal with Impact Engineering. We're a mechanical engineering, buildings engineering company here in Vancouver. And we work, essentially our business focuses on reducing energy consumption in buildings and carbon emissions. So today we wanted to give an overview of some of the technologies that can be implemented to improve energy efficiency and realize low carbon opportunities for buildings. Talk a little bit about our approach and some of the synergies between these technologies and the ability to, for example, provide cooling for buildings. I'll take a look at some of the retrofit technologies and then some of the funding, available funding to support those technologies. Finally, we have a case study of a facility, George Darby Centre, located in Burnaby, BC, that we have conducted energy studies and recommissioning of recently. And yeah, just talk you through some of the examples of the work that we had done, some of the incentives and energy savings. So just a brief introduction. This is Impact Engineering here. Again, we're based in Vancouver, focused on building energy and carbon performance. And myself, I'm a principal here, and then supported by Steve on our team as well on the engineering and implementation side of things. So our typical approach to any building, the existing building side of things, is to provide an energy study or recommissioning study and build a business case analysis for the implementation of potential retrofits. So we work both on the new construction side of things and then also on the existing building side of things. In terms of the new construction side of things, it is much easier, as Abhijeet mentioned, to install low carbon, high efficiency technology at the beginning of a new construction project. It's way more straightforward than existing facilities where you have existing infrastructure that you're limited to using. So yeah, so both new construction and existing buildings are quite unique in terms of the relation to each other and the opportunities that are there. So again, looking at our approach, so when we take on a project, well, we look at these three items as our primary focus for the projects. We look at opportunities to decarbonize and improve the energy efficiency, reduce operating costs for the operator, and then also improve comfort for the occupants. Obviously, the facilities that BC Care oversee, there are many vulnerable populations, so occupant comfort and provisions of effective occupant comfort is of utmost priority to those facilities. So as Abhijeet mentioned as well, there is a transition or a policy trend towards reducing carbon emissions in the built environment. And this is supported or driven, I suppose, on the policy side of things by the BC carbon tax. So over the next 10 years or until 2030, there will be a significant increase in carbon tax in BC. And this will obviously apply to building systems that that use natural gas. So the published target right now is $170 per ton BC carbon tax by 2030. So in reality, if you take average cost of natural gas right now, I'd say perhaps $8.50 or $9, it will almost double the cost of natural gas just in the BC carbon tax alone by 2030. So you can see it's trying to incentivize the move away from natural gas to other fuel opportunities like renewable natural gas or electrification. And this graph basically shows why that is the case. So looking at the carbon intensity of the electricity, both our energy and electricity are a fraction of the carbon intensity of natural gas. And that's why the trend is again moving away towards alternative fuels and electrification. So obviously everyone's very aware of the heat dome that was in BC across the province last year and some of the negative effects of that. So when we are looking at system options, whether it be on the new construction side of things or existing building retrofits, we often look at occupant comfort as a priority as well. And building overheating and the provision of cooling is one of those key areas that we like to focus on. So one of the key benefits, one of the opportunities we look at when we are trying to address building overheating is looking at the opportunities for heat pumps, the provision of heat pumps for buildings. Obviously, they have the benefit of providing low carbon heating, but also on the cooling side of things as well. So these are one of the key synergies we look at when reviewing opportunities. And then also on the passive design side of things and also on heat recovery. I suppose as a philosophy, when we look at both new and existing building construction types, the opportunity to reclaim or recover heat is obviously preferential in terms of just fuel switching 100% of the load, because it's free. Capturing heat is essentially a free technology. So we also look at passive design as well to try and use natural ventilation or shading, for example, to limit the loads on the building mechanical systems. Primarily in summertime as well, we try to limit building overheating and heating within the facilities. So essentially, that's our approach. We look at opportunities for improved efficiencies, reduced costs, low carbon options, and then occupant comfort being a primary goal. So, and I wanted to go through some of the potential retrofit technologies that we look at in comparison to older, more traditional type systems. So breaking it down by system type. So first of all, looking at heating and cooling systems. Traditionally, boilers have been the primary source of building heating for many of the facilities that you operate. There are high efficiency gas boiler options available right now, and a lot of our projects where electrification may not be an opportunity will go towards the condensing gas boiler option. And these new boiler technologies, we can achieve an efficiency of around 95% over standard efficiency boilers. Often legacy boilers can be 80% or less. So there's a big opportunity to have a significant energy saving right off the bat by installing condensing gas boilers. It is important that they are operated effectively. Obviously, condensing gas boilers are at their most efficient at lower supply water temperatures. So and that's something we also consider when installing these or recommending their installation for facilities. As Abhijeet mentioned as well, there are opportunities for natural gas heat pumps. I believe there's some feasibility studies that Fortis are currently leading and have information on to look at how these heat pumps, natural gas heat pumps, can be implemented on facilities. They are greater than 100% efficiency and up to around 140%, 150% efficient. So, and again, as Abhijeet mentioned, after 2030, with the requirement to have all equipment greater than 100% efficient, this is another opportunity in the future. And then on the electric side of things, our source heat pumps or water-to-water heat pumps are other key opportunities within facilities to provide not only heating, but also cooling. And that is the real key benefit for heat pumps. On the ventilation side of things, so again, we look at opportunities for heat recovery as a priority. Again, it's easier to recover heat than it is to install a heat pump or other gas technology to replace that heat. So this is really our the first opportunity that we try and identify. And then on the right-hand side, you'll see these are heat pump ventilation units. So many of your facilities will have rooftop ventilation units that have traditionally been perhaps gas-fired with cooling coil potentially. These newer type systems that are coming through, they provide their heat pump technology, so they provide heating using the heat pump, and often they also can provide cooling as well, which is a key added benefit. And these can come with natural gas backup just to provide that additional capacity in colder climate. On the domestic hot water side of things, there's really two key technologies we focus on. Again, on the condensing gas side of things, where we can get efficiencies of up to 95% on the domestic hot water side, and then increasingly on the electrification or electric side technology, looking at air source heat pumps. This example is a sand and CO2 heat pump. So we can get efficiencies or COPs of greater than 3.5 with these units, obviously changing with outdoor air temperature. And is a really, so these essentially are greater than 300% efficient, 350% efficient technologies. So yeah, it's a really good opportunity where you have electrical capacity and space to place these units. And then sort of some of the miscellaneous systems that we've also been looking at. Laundry is a key energy consumer within many care facilities. We have recently, supported by Fortis BC, we recently conducted an M&V, an assessment, a technology assessment on this Lux laundry system, which essentially uses oxidation and the oxidation process to replace domestic hot water, need for domestic hot water in the washing process. So through our M&V analysis, we've actually identified that there's an opportunity for up to between 60 and 75% savings on the domestic hot water side from using this technology. The two facilities that we looked at, one was for Baptist Housing and one was for Menno Home. Baptist Housing was in White Rock and then Menno in Abbotsford. So yeah, we have really good savings from this technology, and yeah, we're continuing to look at it for other facilities. And then finally, so especially on the existing building side of things, often when we implement new technologies, retrofit technologies, it's really important to ensure that those new technologies are integrated and incorporated effectively into the buildings, into the other building systems. We also place a big emphasis on building recommissioning and utilizing the building management system to ensure all of the systems are programmed and are operating effectively with each other. I can go through a little bit in the case study later on. This is at George Derby Centre. After we completed the retrofits, we also completed a building recommissioning, and it was really effective in troubleshooting and yeah, just ensuring all of the systems were operating optimally. Yeah, so in terms of funding, so obviously these are all of the different types of retrofit technologies. Some may apply more than others for different facilities. So often the first step in making that evaluation is to conduct an energy study. And Fortis BC and CleanBC both provide incentives to conduct an energy study. Fortis BC provide 75% funding and CleanBC 50% funding for energy study. And with this funding, it basically allows the evaluation of those different technologies and the development of a business case to help their implementation. Finally, from BC Hydro and actually Fortis BC, they also provide funding for building recommissioning opportunities. So again, looking at using the building management system, the BMS, as a key tool in evaluating system performance, and providing solutions to ensure all systems are operating effectively. The recommissioning opportunities are more focused on lower payback opportunities, typically around the 2 years, whereas the CleanBC and Fortis energy study incentives are more focused on larger capital upgrades. Okay, so let's jump into our case study. So this is the George Derby Centre located in Burnaby, BC. So we were engaged in 2019 by the centre basically to conduct an energy study and provide some business case analysis and incentive funding for retrofit technologies at the facility. Many of the existing boiler systems, pumps, and ventilation systems were installed in the early 90s, so were approaching or had exceeded their expected life expectancy. So the facilities team there brought us on board to obviously develop solutions, retrofit opportunities, and then also bring some incentives to the table. So the facility itself, it's a two-story long-term care facility. It's 130,000 square feet and has a capacity for 300 beds. And again, when we started off the project, the challenge really was fourfold. We wanted to improve the building energy performance and reduce costs, operating costs where possible, replace the older equipment with more modern alternatives, and potentially leverage some funding to renew some cooling systems in the facility. Obviously, given it's a 24-hour operating facility, equipment downtime was a key concern with us. So a lot of our focus was on ensuring that the recommendations didn't impact service to the building and could actually be retrofit while the facility was still operational. And then finally, again, recommissioning building systems just to ensure that optimal performance. So obviously, we were looking at replacing single systems with new systems, and we wanted to ensure that everything was coordinated and the facility was operating effectively post retrofit. So so just in terms of the steps that we took, again in 2019, we were engaged on the energy study. Energy study is is there essentially to analyze and put forward potential retrofit opportunities. So looking at it from developing a business case from an operating cost, capital cost, and then potential operating cost savings. And then also factoring in incentive dollars from Fortis BC. So we conducted a study in 2019. Actually, Steve from our team conducted a study from our team in 2019, and essentially created a menu of retrofit opportunities. We then worked with Fortis BC to analyze those opportunities and evaluate those opportunities, and then Fortis came to the table with some incentive fundings to ensure that the retrofits could go ahead. So then next step was we did some detailed design. So we had the opportunities assessment, we had the funding from Fortis BC, and then the ownership team made a commitment in terms of capital outlay, and we began the design and implementation of those measures over the course of 2020 and 2021. We were looking at both primarily the heating system, domestic hot water system, but also reviewed cooling and ventilation systems as a priority. Obviously, with COVID and the outbreak of COVID in 2020, this was also a key focus for us in terms of air quality. And then finally, once the design and implementation was completed, we conducted a recommissioning exercise. And this, again, the focus was ensuring that the new boilers were effectively operating, working at optimal supply water temperatures, that were integrated into the heating system effectively, that the pumps and everything were working well. So yeah, this was the final piece of the puzzle. And again, we got funding from BC Hydro to conduct this recommissioning study. And I have just some photographs at a very high level just to showcase, what was there originally, and then what was replaced. So these were existing standard efficiency Unilux boilers that were there at the beginning of the project. Again, they were approaching end of life. I think they were, it could have been in excess of 25 years old, and we're having some performance issues. So we proposed to replace those older units with new Viessmann condensing gas boilers that were operating at an efficiency of design efficiency of around 95%. Obviously, we're getting those temperatures when the supply water temperatures are around 60 degrees Celsius or lower. So part of the recommissioning exercise that we did was to ensure that these new boilers were operating in the condensing range as much as possible. Another part of the key retrofit was that we separated the domestic hot water system from the heating system from the old boiler system. These are two RBI boilers that were installed to provide domestic hot water, and you can see at the rear there we also put in another 4 new domestic hot water tanks. And uniquely so on the domestic hot water side of things as well, we also were able to leverage some incentives to provide heat recovery through a water-to-water heat pump. So within the facility, like many care facilities, there was a distributed heat pump system to provide heating and cooling to the core of the facility. So in summertime, those heat pumps rejected heat from the condenser water loop out through the cooling tower here to the atmosphere. So one of the key retrofits also in this was we installed a water-to-water heat pump in the mechanical room, and it captured heat that would otherwise have been rejected out through the cooling tower in summertime to provide domestic hot water heating. So it's kind of an innovative and a hybrid approach to obviously looking at our core goals of decarbonization and energy efficiency as well in the facility. Within the core of the facility as well, looking at both indoor air quality and the condition of some of the existing ventilation systems, we also proposed to install a heat recovery ventilation system that would provide effective ventilation up to the latest codes for the interior spaces. And this oxygenate heat recovery ventilation system essentially captures heat from the air or cooling in summer from the air and exchanges it with incoming air to provide effective ventilation for the space. Part of this project was also replacing older heat pump systems, distributed heat pump systems with new heat pumps, just to ensure resiliency and to ensure they were operating effectively as needed during summer. And then finally, once we had conducted all of those retrofits, we looked at the recommissioning opportunities as well. So the facility had some legacy pneumatic controllers and valves located in the facility. So part of our work as well was to exchange those pneumatic system to an electronic system. And then also as part of the recommissioning exercise to utilize the building management system to identify opportunities for improved energy efficiency. And I'm not sure if you guys can see, but in this top right-hand corner is a really good example of this. So the top left there's four large, I think they're 15,000 CFM ventilation units, 4 of which serve the facility. So total 60,000 CFM of air to the facility. And these are 100% outdoor air. So in order just to prevent a lot of that heat from the facility being wasted, these systems were designed with a heat recovery loop on the ventilation systems. So as part of the recommissioning study that we identified that these loops were not operating effectively, that the glycol in the heat recovery had leaked, and that the pumps were no longer operational. So we were able to engage with the mechanical contractor and have this resolved. And this is a really good example of a low-cost measure that has a big impact on energy efficiency and energy savings within the facility. So that's that. And then just a bit of a recap. We were able to leverage several different incentive streams for the retrofits in the facility, and it totaled up to around $425,000 in total incentive funding, both for the studies and then the implementation support. And these came from Fortis BC, they came from CleanBC, and some other funding organizations. And with this funding, we were able to obviously implement the retrofit measures that were identified in the energy study, which resulted in a 20% reduction in natural gas consumption. And this was taken, we just checked the utility consumption bills last week. This was 2021 data in comparison to 2020 data. There was a 20% reduction in natural gas consumption at the facility. And the positive side with that is that even in 2021, we were still commissioning and recommissioning a lot of the systems. So we anticipate that this number will actually increase as those systems get fully commissioned and operational. But even with the 20% reduction, it led to a 30% reduction in utility costs and natural gas costs to the owner per year. And again, looking at the carbon tax increases that are projected over time, I mean, this would be at 2030 values. Just looking at the carbon tax alone, this is $60,000. So you can see that the return on investment, which, return on investment at 2021 dollars were anywhere between 2 and 10 years. So obviously, as those incentives or the carbon tax hikes come in place, those returns will improve over time as well, and the paybacks will be reduced. And ultimately, something I think that the team were proud of was that we did provide increased resiliency and comfort for the residents of the facility. We ensured the cooling systems were operating optimally, indoor air quality was improved, and ultimately, when we're faced with the next extreme weather event in perhaps next summer, hopefully not, but perhaps next summer, the facility is more resilient to be able to cope with those higher temperatures. Okay, so I just tried to keep it brief enough, keep it at a high enough level just to go through those opportunities, and welcome any questions that you guys may have.
Right, thank you, Kenny. We have a question in the chat. So the question is, what's the justification for using a gas-fired heat pump instead of electric heat pump? So taking up that, Kerry, you can add to that what I'll be mentioning. So the information I had about the gas-fired heat pumps is it doesn't use ozone-damaging refrigerants under high pressure. Rather, they use ammonia as a natural refrigerant with water as an absorber. And the other is at extreme cold temperatures and freezing temperatures, gas-fired heat pumps work very efficiently as compared to electric heat pumps, which are struggling during those temperatures, and which, like if you see some newses and some incident happened in the past, so gas-fired like electric heat pumps were not able to heat the building, and in those cases. People have to use their natural gas boilers again. And the other is in case of power failure. So we had this example in Texas last year where the electric grid got failed because of the storm. So gas-fired heat pumps would be still keeping the building cool or warm in case of power failure as well. So these are the like 3 points which I understood. They have like these are the more advantage over electric heat pumps as compared to gas-fired heat pumps. And Kenny, would you like to add something on that?
Yeah, I think that's a good summary, Abhijeet. There are benefits and drawbacks with both technologies. The added benefit with on electric heat pumps is that they also provide cooling as well. So you're able to get that added benefit of cooling. But this is where the assessment comes in, I think, at an early level in a project where both technologies can be assessed together, and then the best opportunity can be moved forward with.
Yeah, so I have added a link which I found that the pilot which happened in BC on gas-fired heat pump on Fortis BC. So that I have put, you can go through that and browse through the Fortis BC website. You will definitely find some like the whole report on the pilot, and yeah, that should be useful. Any other questions regarding the program, rebate, energy efficiency measures used, or from the case study? And instead of typing, if you want to like speak now, you can unmute your microphones and you can share. So yeah, one we have raised. Yeah, please Harshit. Yeah.
Yeah, thanks, Abhijeet. Hi, Kenny. I'm Harshit, currently working as the energy analyst with Tota. My question was with regards to the oxidation process in the Lux laundry system. So if you can elaborate a bit more on that, what is it? And how it saves hot water?
Yeah, so this technology, it uses UV light it basically uses room air. It draws room air into the technology. It uses UV light to create oxidizers, hydroxyl radicals, I think is what the correct chemical term is. But basically, it oxidizes, uses UV light to get the oxidation process, and then that is fed into the washers. And what it essentially does is, in order to create effectively clean laundry, you need to use a lot of domestic hot water. So what this technology does is that it reduces the requirement for domestic hot water. So I think by, as I said, between 60 and 80%, depends on the load type, and just replaces it with cold water, and then the hydroxyl process. So it essentially effectively reduces the requirement for hot water in the wash process.
Thanks, Kenny. And my other question was, so you mentioned about this incentive or this funding which is available for the energy efficiency study. So if you can guide me on that, do we engage a company like Impact to get this study done through them, through your company? This is done, or how does that work if I want to get it done for my organization or for my stakeholders?
Yes, so essentially you would work with Abhijeet, basically to let just to let him know that you'd be interested in conducting a study. So the studies themselves have to be conducted by an organization like Impact Engineering. We have to be registered to provide the studies through Fortis BC. And yeah, so I'd say if you have an opportunity in mind, the first step would be to connect with Abhijeet, and then he can provide you the full list of opportunities, I suppose, from the incentive funding side of things.
Right. And adding to it, Harshit, it's something like earlier it was a gas technology program through which this technology is being approved. And now it comes under custom rebate program. So when you conduct a custom rebate program, you have to get a whole building energy assessment done through that program. So where the engineering consulting firms like Impact Engineering and other registered firms, which you can find on the Fortis BC website. So those companies come in, they do the audit. After that, they will tell that there are like these 5-6 energy efficiency measures which can be implemented. And for implementing, you get like separate rebate on that. For the study, you have a rebate, and for the implementation, you have a rebate. And then after that, you do measurement and verification. For that, you have a rebate. So I would suggest like you can directly go through the website and see the custom rebate program. So this technology completely applicable to the custom rebate program of Fortis BC. And if you have anything, please email me.
Got it. Thank you. Thank you, Abhijeet. Yeah.
Right. So yeah, we are pretty saved on time, and I think if you have any questions regarding this webinar or anything else regarding program, you may contact me and Kenneth. So I'll be posting this presentation on the website of the BC Care Providers Association Energy Savings Program page, and you can access the webinar as well as you can download this presentation if you want and keep it and for your reference or for education. And then I'll be and you can have the Kenneth email as well. So yeah, you can approach them as well.
Thanks, Abhijeet. Thank you. Yeah.
Thank you. So we sign off, and I'll stop the recording now. Thank you, everyone, for joining. Thanks again.
Thanks, everybody. Have a good week.
Thank you, Abhijeet. Thank you, Kenny.
Bye-bye.